Welcome to Fun Facts Online. In a world where the story of our climate is often one of melting ice and rising seas, there's a place high in the mountains that seems to be playing by a different set of rules. Imagine a vast kingdom of ice, straddling the borders of Pakistan, India, and China, where glaciers aren't just holding on, some are actually growing. This isn't science fiction. It's a real-world scientific puzzle known as the Karakoram Anomaly. High in the rugged, unforgiving expanse of the Karakoram mountain range, many glaciers are defying the global trend of retreat. They are stable, and in some cases, expanding, a stark defiance that has captivated scientists for decades. Let's delve into this bastion of ice in a warming world. The Karakoram Range is a part of the greater Hindu Kush Himalaya region, and is one of the most heavily glaciated areas outside of the polar regions. This is a land of giants. It's home to K2, the world's second highest peak, and thousands of other towering summits. These mountains cradle colossal glaciers like the Siachen and Biafo, which are among the largest outside the Arctic and Antarctic. For millions of people living downstream in the arid regions of South and Central Asia, the meltwater from these immense frozen reservoirs is nothing short of a lifeline. The story of this strange anomaly really began to gain traction in the scientific community in the late 1990s and early 2000s, as the overwhelming majority of the world's glaciers were succumbing to rising temperatures. Observations in the central Karakoram painted a startlingly different picture. Geology professor Kenneth Hewitt was one of the first to formally describe this behavior in a 2005 paper, highlighting observed mass gains in the 1990s and setting the stage for years of intensive research. So what is causing this incredible phenomenon? The primary explanation lies in the unique weather that governs this high-altitude region. Think of it as a tale of two climate systems. Most of the Himalayas get their rain and snow from the summer monsoon, which sweeps up from the Indian Ocean. But the Karakoram is different. It's predominantly fed by another weather system entirely, the mid-latitude westerlies. These are powerful winds that originate thousands of kilometers away over the Mediterranean and Caspian seas. They carry moisture-laden storms eastward, delivering them to the Karakoram primarily during the cold winter months. This winter precipitation is the key. Recent research has shown that these storms, often called Western Disturbances, are the main reason for the anomaly. Studies suggest that these disturbances are the primary source of snowfall for the region in winter, contributing to as much as 65% of the total seasonal snowfall volume. And here's the crucial part: the intensity of the precipitation from these disturbances has actually increased by approximately 10% in the last 2 decades. While other parts of the Himalayas are experiencing declining snowfall, the Karakoram is receiving a steadier and, in some cases, increased supply, allowing its glaciers to accumulate mass and hold their ground. In stark contrast, precipitation from other non-westerly sources has seen a significant decrease. So, it's this specific revival and intensification of the westerly winds that is nourishing the Karakoram's glaciers. But there's another layer to this climatic puzzle. Scientists have discovered a large-scale circulation system, essentially a giant vortex of cold air, that forms over the Karakoram. This vortex has a profound impact on the regional climate, especially during the summer. In the winter, the vortex influences the temperature over the entire 2,000-kilometer mountain range. But during the summer, it contracts, concentrating its cooling effect specifically over the Karakoram and the neighboring western Pamir Mountains. This summer cooling is a critical piece of the puzzle. It creates a stark temperature contrast with the rest of the Himalayas, which are experiencing distinct warming trends. This localized cooling effect means that even as global temperatures rise, the Karakoram summers are just cool enough to prevent the kind of rapid melting seen elsewhere. The presence of this vortex helps to explain why climate models have often struggled to get the Karakoram right. While most models predict warming across the entire Himalayan region, they were missing this localized cooling effect, this giant atmospheric shield protecting the ice below. Now, before the roles of the westerlies and the vortex were fully understood, an early hypothesis centered on something you can see just by looking at the glaciers: debris. Karakoram glaciers are famously dirty. As they grind their way down valleys, they scrape up and transport vast amounts of rock and sediment. This debris settles on the surface of the ice. The theory went that this thick layer of debris was acting like a blanket, insulating the ice from the sun. It's true that debris cover plays a role. A thin layer of dark debris can actually absorb more solar radiation and accelerate melting. But a thicker layer, typically more than a few centimeters, does act as an insulating blanket, protecting the ice and slowing down the rate of melting and evaporation, a process called ablation. Studies suggest this debris cover reduces basin-wide ablation by around 14%. However, this is no longer considered the primary driver of the anomaly. For one, the phenomenon affects both debris-covered and clean ice glaciers, which pointed towards a larger-scale climatic explanation. More importantly, the sudden onset of glacier stability and expansion in the late 1990s suggested a dynamic process was at play. The debris cover isn't a new thing. It's been there for centuries. It couldn't explain the relatively recent change. The true cause had to be climatic, pointing back to the changes in the westerlies and the summer vortex. The Karakoram Anomaly isn't just a scientific curiosity. It has profound, real-world consequences for the millions of people who depend on the region's water. The stability of these glaciers provides a crucial buffer against water scarcity, especially as the climate changes. The meltwater from the Karakoram feeds major river systems like the Indus, which is vital for agriculture, hydropower, and drinking water for huge populations in Pakistan and India. In a sense, the anomaly has been a blessing, ensuring a more reliable water supply than might otherwise be expected. Development in the region, like the famous Karakoram Highway, has already brought significant socio-economic changes, increasing access to markets, education, and healthcare. But the very glaciers that make this region so vital are also a source of significant danger. The advancement of some glaciers, a direct result of the anomaly, has led to the formation of ice-dammed lakes. These lakes can form when a glacier blocks a river or tributary. As the lake fills, the pressure on the ice dam increases until it bursts, causing a devastating glacial lake outburst flood, or GLOF. These floods are incredibly destructive, releasing massive volumes of water and debris that can wipe out entire villages, roads, and bridges downstream. This poses a significant threat to communities and major infrastructure projects, including the multi-billion-dollar China-Pakistan Economic Corridor. So what does the future hold for this incredible anomaly? This is a subject of intense scientific debate. The big question is, how long can it last? Some climate models suggest that the unique conditions sustaining the anomaly could persist until the end of the century. However, other models and more recent studies indicate a potential weakening of this unusual behavior. In fact, some research suggests the anomaly may have already ended in the last decade, with some glaciers in the region now beginning to show signs of mass loss, falling in line with the global trend. The case of Norwegian glaciers offers a cautionary tale. In the 1990s, many glaciers in Norway experienced a period of growth, much like the Karakoram. But in the 2000s, their mass balance turned sharply negative, and they began to retreat rapidly. The long-term persistence of the Karakoram anomaly in a world of continued and accelerating warming seems, to many scientists, unlikely. Ultimately, the Karakoram anomaly is a powerful reminder of how intricate, complex, and often counterintuitive our planet's climate system is. It shows that while the global trend of warming is undeniable, its effects can vary dramatically from one region to another. This bastion of ice in a warming world offers a unique natural laboratory, a place where scientists can study the complex interplay of atmospheric circulation, mountain topography, and glacial dynamics in real time. The ongoing research in the Karakoram is not just about solving a fascinating scientific puzzle. It's about understanding the future of one of the world's most critical water towers. and helping to ensure the resilience of the millions of people who depend on it for their survival. The story of the Karakoram stable and growing glaciers is a testament to the complexity of our planet, and a compelling call for continued scientific exploration in the face of a changing climate. Thanks for tuning in to Fun Facts Online.